Right, continuing on with the scientific method. When we left off in our last PowerPoint, we were talking about results and quantitative versus qualitative data. And we always said that you have to organize that data in a table and then, if possible, put that into a graph. And so, what we're going to focus on for this PowerPoint is learning target number 2. How do you organize and draw conclusions from data found in a table and graph? And so before you can even draw conclusions from it, you have to actually organize and get that data into a table. So we're going to focus on tables in this PowerPoint, and then we'll get to graphs in the next PowerPoint. So when we look at data tables, the reason you have to always know what your independent variable is and your dependent variable in your experiment is that is what's going to help you organize your table and also ultimately your graph. And so when you're making a data table, data tables have columns and rows in them. The columns always need to have headings, okay, and units if possible. So here are both the headings here, and there you've got the units. The first column is always going to be your independent variable. That's going to be something that the researcher is going to change. Okay, so in this case, this researcher is looking at different depths. Okay, so he's going to change and determine at which depths does he want to test. And what he's trying to measure is the basalt melting temperature. So that's your dependent variable. So that's always going to go in the column to the right of your independent variable. So always, always, always put your independent variable first in that first column. All right? And so what we're comparing here is the researcher is changing and looking at the different depths, and then it's going to compare what are the different basalt melting temperatures at those different depths. But what is this table missing? Can anybody guess? It is missing a title. Okay? So, it's very, very important that you have a very good and specific title on both your table and your graph. And you can use the same title for both because really if you make a good table, that's what your data is going to be then converted into a graph. It's going to show the same thing, it's just in a different format. So you can use the same title for both. But it has to be descriptive and specific. Okay? It has to include your independent and dependent variables. It has to include those two things. So, an example might be the amount of rainfall per day in June. Well, what the researcher is changing and looking at differently is the different days. So that's the independent variable. What they are measuring is the amount of rainfall in each of those different days that they chose. That's your dependent variable. And so oftentimes, a very easy way to write a title to make sure you have both your independent and dependent variable in there is to take your dependent variable versus your independent variable. So, for example, the temperature of water in degrees Celsius versus the heating time. I'm going to change how long I take to heat the water, and then I'm going to measure the temperature of the water in degrees Celsius. So this right here is my independent variable, and the temperature of the water is my dependent variable. And then whenever possible, make sure you use units. Sorry, can't read my writing on this chicken scratch on these things. Okay, so let's do a little practice here. It says, Mrs. Baltazar surveyed her class to find out what their favorite candy bar was, or favorite candy was. Here are the results. 10 like Reese's peanut bar cups, 5 like Skittles, 3 like Starburst, 4 like Kit Kat bars, and 2 like Snickers. Create a table with an appropriate title in the space below. Well, what's the first thing we are going to do? Let's just draw. Remember, tables are kind of either rectangular or squarish with rows and columns. I know I'm going to need one spot there for my heading, okay? And then I have one Reese's Peanut Butter Cup. So 1, Skittles, 2, 3, 4, 5 different things I want to show. So I have to make sure I have 1, 2, 3, 4, 5. Okay? And then I'm just going to draw a line down here. And what should I do for my first heading? What goes in here again? The first column is your independent variable. What did I change between all these? I changed the type of candy, right? Okay. In the next column is your dependent variable. And what did each of these numbers refer to? Those are the number of students who chose that particular candy. So, I'll just number of students choosing. Okay. So let's start getting things organized a little bit here. So I'm going to put my Reese's Peanut Butter Cups. I'm just going to abbreviate it right now because I'm afraid I'm not going to be able to fit everything in there. I'll do P, B, C. Okay. And then Skittles, Starburst, Kit Kat bars, Snickers. Okay, make sure you're doing this with me because you're going to have to be able to do this on quizzes and tests and in your labs. So the more practice you get, the better you'll be at this. So there were 10 that liked Reese's Peanut Butter Cups, 5 that liked Skittles, 3 Starburst, 4 Kit Kat, and 2 like Snickers. Okay? So, appropriate title. We have to have a title on there. Remember, that can be your dependent variable versus your independent variable. So we can just say number of students choosing types of candy. Okay, that's it. We've got everything we need there. We've got our independent variable and dependent variable in our title. We've got a heading there with our independent variable from the first column. We have a heading with our dependent variable in the second column. And then we've listed everything out. So it's very neat and orderly. Okay. From there, we're going to display that information in a graph. Okay. And there's a number of different types of graphs that we can use. One of them is a line graph. That's when you're going to show how numbers have changed over time. And it also shows you data that are connected. So those are two main things that you're going to use to determine should this be a line graph or not. A lot of times if we see dates or things like that, we say, oh yeah, it's showing change over time, showing how much that plant grew over so many days. Then we know that's a line graph. But sometimes it's to show that two different sets of data are connected. And it can also be used to show trends as well. Okay? Trends between two sets of information. So there you can see an example of a line graph. Okay? A second type of graph is a bar graph or a histogram. This shows numbers that are independent of each other, and it shows bars to show how large each category is. Okay, so the bars show how large each category is, and it shows things that are independent of each other. So these different age groups are not dependent on each other at all. They're just showing the number of people in each age group. Okay, so that would be more appropriate to use a bar graph for that example. A pie graph or a circle graph shows how a whole is divided into different parts, and it also shows the percentage or proportions. Now, oftentimes, even if we're going to show percentages in class for certain labs, it's okay if you still were to show that in a bar graph or histogram type of thing. But if you were able to do it into a pie graph, that would be fine too, because that's generally where you can see the fractions or the proportion or the percentages of different things. In this case, the favorite type of movie that people like. Now, one that you're probably not as familiar with is a scatter plot. Scatter plot uses dots to represent values obtained for two different variables, one that's plotted along the x-axis and the other plotted along the y-axis. And you use these, you want to show a relationship between two variables, okay? You want to show how the two variables are correlated. So how are they related to each other? And there's three basic possible things that you can show here. When you see this one here, it's showing you that as one thing increases, so does the other. That's a positive correlation. So as one variable, increasing one variable will cause an increase in another variable. So that's when you see that they're all kind of clustered around, almost forming this nice line going up towards the right there. Now, if it's a negative correlation, now you're going to see them all clustered, but it's going to be more dropping down to the right. That's a negative correlation. That's where when you increase one variable, it's going to cause a decrease in another variable, okay? So as you're increasing one, it's decreasing the other. Now, if there's no correlation at all, that means there's absolutely no relationship between the variables, okay? And that's this one up here. They're just all over the place. It's not like you can draw a line there. They're just everywhere, okay? So there's no relationship between those two variables at all. So those are the different kinds of common graphs that we might be using in biology class.